On June 30th, 1908, in the remote heart of Siberia, an unimaginable force erupted. The sky above the vast taiga forest suddenly ignited with a blinding flash, turning night into an instant, searing day. This was no ordinary sunrise. Moments later, a colossal explosion ripped through the atmosphere, unleashing energy equivalent to thousands of Hiroshima bombs. The shockwave, a terrifying invisible hammer, flattened an astonishing 80 million trees across 800 square miles. This cataclysmic event registered on seismic stations across Europe, and atmospheric pressure fluctuations were detected as far away as Great Britain. Yet, despite its immense power, the source of this devastation remained elusive. There was no impact crater, no definitive meteor fragments, and no clear explanation for the sheer scale of destruction. This was the Tunguska Event, a cosmic enigma that continues to baffle scientists and ignite the imagination. Eyewitnesses, scattered across hundreds of miles, recounted a terrifying spectacle. Many described a brilliant, fiery object streaking across the sky, accompanied by deafening thunder. The ground trembled violently, and buildings shook as if in a powerful earthquake. People were thrown from their feet, windows shattered, and distant villages experienced intense heat. Some reported a pillar of fire rising into the sky, followed by a mushroom cloud, eerily prescient of future man-made horrors. The sheer intensity of the light was said to have caused temporary blindness for those who dared to look directly at the celestial phenomenon. The heat was so profound that it scorched clothing and caused minor burns on exposed skin, even at considerable distances. The sound was described as a series of thunderous roars, culminating in a single deafening blast that echoed for hundreds of miles. This was not merely a distant rumble, it was a visceral assault on the senses, leaving an indelible mark on those who experienced it. When the first scientific expedition finally reached the remote Tunguska site years later, they found a scene of unparalleled devastation. Millions of trees lay radially flattened, pointing away from a central point, like spokes on a colossal wheel. Yet, at the very epicenter of this destruction, a strange anomaly persisted. A patch of trees stood upright, though stripped of their branches and bark, appearing as ghostly charred poles. This peculiar pattern defied conventional impact theories. The ground itself showed no signs of a massive crater, which would be expected from an object of such immense destructive power. There was no deep depression, no excavated earth, just the eerie silence of a forest violently rearranged. Furthermore, despite extensive searching, no significant meteoritic fragments or debris were ever conclusively found. This absence of physical evidence became the central paradox of the Tunguska Event, deepening its mystery. The remoteness of the Tunguska region, coupled with the political turmoil of early 20th century Russia, meant that a proper scientific investigation was delayed for years. The first significant expedition didn't arrive until 1927, nearly 2 decades after the event. Led by Soviet mineralogist Leonid Kulik, these early teams faced immense logistical challenges, navigating dense forests and treacherous terrain. Their initial findings confirmed the widespread devastation, but offered no immediate answers to the cause. Kulik dedicated his life to unraveling the Tunguska mystery, convinced it was a massive meteorite impact. He meticulously mapped the blast zone and searched tirelessly for the elusive crater and meteor fragments, but his efforts proved fruitless. His persistence, however, laid the groundwork for future research, drawing global attention to this extraordinary phenomenon. Without his pioneering work, the Tunguska Event might have remained a forgotten footnote in history. Today, the most widely accepted scientific explanation for the Tunguska Event is the airburst hypothesis. This theory posits that a large celestial object, likely a stony asteroid or a comet, entered Earth's atmosphere and exploded before reaching the ground. As the object plunged through the atmosphere, intense atmospheric pressure and friction caused it to heat rapidly. The immense stress built up within the object, leading to a catastrophic disintegration at an altitude of several miles. This mid-air explosion would have released its energy in a powerful shockwave that propagated downwards, explaining the radial flattening of trees without creating a crater. The energy released is estimated to have been between 10 and 30 megatons of TNT. This theory accounts for the lack of a crater and the widespread outward-directed damage. However, it still struggles to fully explain the complete absence of any significant meteoritic debris, even microscopic particles. The persistent puzzle of the Tunguska event lies in the almost complete lack of physical remnants. If a stony asteroid exploded, even in an airburst, one would expect at least some fragments, dust, or melted material to be scattered across the blast zone. While some microscopic particles of extraterrestrial origin have been identified in the soil, they are not conclusive proof of a large meteoritic body. Their scarcity remains a significant challenge for the asteroid hypothesis. This absence has led some scientists to favor the idea of a cometary impact. Comets are primarily composed of ice, dust, and frozen gases, making them far more volatile than stony asteroids. A cometary body would likely vaporize almost entirely upon atmospheric entry and explosion, leaving behind little to no solid residue. This would neatly explain the clean slate left at Tunguska. The comet hypothesis suggests that the Tunguska object was a small, icy comet that disintegrated completely in the atmosphere. Its composition would allow for a powerful airburst without leaving behind any substantial solid fragments. As the comet entered the atmosphere, its icy components would rapidly sublimate and vaporize due to intense heat and pressure. This process would lead to a spectacular explosion, releasing its kinetic energy as a massive shockwave. The lack of a crater and the absence of large meteoritic debris are strong points in favor of this theory. However, proving it definitively without direct evidence of a comet's composition remains a challenge. Despite the compelling arguments, the comet hypothesis is not without its own questions. Some argue that a comet of that size would have been observed in the night sky for days or weeks prior, which was not the case. While the airburst theory, whether asteroid or comet, remains the scientific consensus, the enduring mystery of Tunguska has naturally spawned a host of more speculative, even fantastical, alternative explanations. These theories, though lacking scientific proof, highlight the event's profound intrigue. One popular, albeit unproven idea suggests that the Tunguska event was caused by a miniature black hole passing through Earth. This would explain the immense energy release and the lack of physical debris, as the black hole would simply pass through. Another intriguing, though highly improbable theory links the event to Nikola Tesla. Some propose that Tesla's experimental wireless energy transmission, perhaps a misfired beam from his Wardenclyffe Tower, somehow caused the explosion. More outlandish theories include the crash of an alien spacecraft, its advanced propulsion system causing the blast, or even a localized volcanic gas explosion from deep within the Earth. These ideas, while captivating, lack any credible evidence. The Tunguska event stands as the largest impact event on Earth in recorded history that was not caused by humans. It serves as a stark and powerful reminder of our planet's vulnerability to cosmic threats. It demonstrates that even a relatively small object exploding high in the atmosphere can unleash devastating power. This event has profoundly influenced our understanding of asteroid and comet hazards. The study of Tunguska has directly contributed to the development of planetary defense strategies and early warning systems. It underscores the importance of tracking near-Earth objects to prevent future catastrophic impacts. Ultimately, the Tunguska event is a testament to the universe's unpredictable nature and the enduring mysteries that lie within our own planet's history. It reminds us that even the biggest blasts can leave behind more questions than answers. The Tunguska event remains one of the most captivating and perplexing mysteries of the 20th century. Its unique characteristics continue to challenge our understanding of cosmic impacts and atmospheric phenomena. Was it a stony asteroid that vaporized completely? A fragile comet that disintegrated without a trace? Or something far stranger that defies our current scientific understanding? The debate continues, fueled by the tantalizing lack of definitive answers. The vast Siberian forest, now largely regrown, holds the secrets of that fateful morning. It stands as a silent monument to an unseen force that shook the Earth, leaving behind a legacy of wonder and scientific pursuit. On one morning in 1908, in the middle of nowhere, the sky exploded, and the echoes of that blast continue to resonate, inviting us to ponder the vastness of space and our place within it. So what do you think hit Tunguska? A space rock, a comet, or something else entirely? Drop your theory in the comments below. And if you're fascinated by history's greatest mysteries, be sure to subscribe to BrainSnack for more intriguing stories made simple.